for tonight. And if you notice, I'm the only cameraman here who was shooting that. So myself, Subrata, I'm part of the Chrome team at Google. So Susan asked me to talk about how open source work at Google. It's a pretty big topic, to be honest, to cover, because Google runs with the fundamental idea of first-party devices should run the first-party code, not third-party code. So our first agenda is that open source first. I think my previous speaker also iterated the same. So like one thing that may be a kind of tagline that I want to have at the end of my career, that I only work on the open source firmware. And from last 15 years, I think that was the case with me. If anything remains persistent in my life, that is me with firmware and firmware that is open source. Right. So I just molded the session to say that it is an open source firmware, just to make sure the audience that we have, I believe there are the firmware engineer, low-level driver, BSP engineer and all. So here's the topic that we want to cover. So let's start with what is firmware. I don't have any giveaway here, but still I want to ask this question: what is firmware? Anybody just raise hand and say that what is firmware? Okay, I think he does first.
Simple interface between software and the hardware.
Okay, perfect. So I think you are not only the person who said it is simple. I think the IEEE also says that it's simple. It says it is tiny and it is read-only, right? And see, just note the year, in which year I think IEEE says that, in 1990, right? That time it's totally perfectly fine. But can we call tiny and read-only for the modern disk firmware? Then Zephyr would have not existed in that way, right? So the right definition would be, for the firmware today, is essential. Whatever is that come next, whether it's tiny, read-only and all, I think it's essential, right? And why it's essential, that shows here, right? You are right, it's a layer between hardware and the kernel, right? But with the amount of job it does, right? So that's the reason I call it essential. And I don't want to go too deep about what the job it does. I have some slide next. So as a company, Google, and as a part of our team, the Chrome OS team, why we invest on the firmware? What's so special on the firmware? It just may be a 1 second. And if you notice, I have a Chromebook here. So our Chromebook has a critical requirement for the productization: 1 second boot time. The moment you power on, right, within 1 second it should see a UI, right? So that is basically our goal. And just for a 1 second, why you hire so many people and why you invest on that, right? Because of this reason. So firmware provides you a consistent behavior. I want to design a Chromebook with Intel, with MediaTek, with Qualcomm, with AMD. I want a consistent behavior. I cannot change my kernel driver every time. I have to call to a lower level hardware, right? Second, it provides a very standard OS interface. I think like many people talk about Zephyr. Why Zephyr is popular? There are lots of RTOS, to be honest, right? And there may be very simple RTOS. But I think Zephyr is popular and going to be popular because the interface is provided. Everybody loves to call an interface because we are in the modular development. Like some of my colleagues work from the different geo and I work from the different geo, right? We want to talk with the same interface. Third is that firmware has been very close to hardware. So whoever work on the hardware part, they know how tough to land the code changes in Linux kernel. Anywhere, you can't convince your hardware engineer to make a change in the hardware when device in the late phase, right, for the productization. But they are always like running to you saying that, can you fix the issue in the firmware, right? So I use maybe a poor joke. I say all the issues are firmware issues until unless somebody prove it is not, right? And one more reason why I say firmware we are investing in security. I think somebody says about CVEs, right? So today, if I ask anybody, I think as a college student, maybe can answer to this question: can I run an application on a ring 0 layer? They will say no, because it's a security, right? So ring 0 is more trusted and all, right? See where we are running firmware. It's a much lower than your kernel layer itself, right? So how can you think? Like, how can you not think about such layer, right, which is running below your ring 0? And I say that it is running at the -1. There are other firmware, right? For example, there are system management mode firmware on x86, on the ARM, right? Those are running at the -2 layer. There are manageability firmware, which allows you to out-of-band access. You don't even know when your IT service manager is able to access your machine, right? So that is the -3. Right, so you have to know that which world you are living in, right? And based on that, your firmware has to be more important. And that's the reason I said that 1990 definition may not be worthy today. But I'm not here to change the IEEE definition, right? What I'm here to talk about a Chromebook platform overview, because this is what my team does in Bangalore, right? And I take care of the firmware. And today's out of interest, we'll just only talk about the embedded controller. It's a pretty big topic. And I have a Chromebook here. So this is a like very high level platform view. You can think I try to put in the 3 layer. One is a microcontroller that we have, which is a embedded controller, PMIC, security chip, TCPC, and the middle there is application processor. It could be any architecture, right? And the right hand side there are peripherals, right? So on a typical Chromebook, we updated around 15 to 18 based on the use case of the maybe the machine, right? So every time when you update the device, we basically update those many firmware, right? Maybe bug fixes, maybe providing some patching, right? Maybe some CVEs and or whatnot, right? So why firmwares are very important and what job we do, it clearly shows here. So I'll just show you in the order of boot. I have a slide next to talk about the boot flow, but I'll just show in the order of boot how the Chrome firmware architecture is. So this is the Chrome firmware architecture. You can think about underlying layer. It's running on, or maybe it is with any SoC architecture, right? And then there is a security chip. We call it as a Google security chip. Like a Titan is one of the example, which is our root of trust. So whatever is running next will be verified by this guy, right? And we use a verified boot, which is again open source. I have a link, or maybe there is a scan code. You just scan, you can see the Chromebook that we kept here, or the Chromebook that I am using, right? It is running open source firmware, open source kernel, everything, right? So like what project it is running, and if you're in developer mode, you can build your own image and you can flash on that, right? So then next come is a embedded controller EC, which is basically important because it releases your or it completes your power sequencing. It releases your processor, your application processor comes out of reset, and not only that, the EC also manages your power state transition. When you close your lid, when you put the power switch off, right? EC is not out of job. Maybe application processor is out of job, but EC is always there. Next is the core boot, which is our boot firmware or system firmware. We say this is again open source piece. I put as O as open source, and so this is basically it does a platform initialization with some of the closed source code because that's a silicon firmware. We cannot complain. Not all silicon vendors are like TI, who says open source is first, right? So some silicon firmware, which is a kind of a mixed hybrid, I call some of the open source, some of the closed source, right? It's a mixed bag in those cases. And finally, it's a depth chart is a payload that is again open source project, which basically designed to boot a Chrome OS. And then finally is a Linux kernel, like operating system is a Chrome OS, which is a flavor of the Linux kernel. And we take the Linux kernel, we put our Chrome OS layer on that. So as we committed to talk on the EC as embedded controller, so this is the EC firmware that we run on the Chrome Chrome OS devices. It could be Chromebook, Chrome OS, Chrome base, anything. Right hand side you can see a typical like embedded controller interface with the different IOs and all, and there's the communications with your SoC, right? So like maybe to take a note of 3 high level communication. One is basically to communicate with your PCH or your SoC, right? It could be LPC, SPI, or I2C, whatever is that. And second is that the power sequencing, because your SoC is not up until there is a EC completes those power sequencing. And after the power sequencing is done, right? Maybe EC and the AP, they communicate with it between each other. And what for they communicate? They communicate for certain applications, and those are the applications, right? So the responsibility of the EC firmware is nothing but running those applications. One is the power sequencing. I already talked about that, right? Second is the peripheral management. So like on my Chromebook, you have lots of button, volume button, you have EC switches and all, right? So whenever you press that, like managing those buttons and all, right, those GPIOs are also routed to the peripheral. And I'll come later. I think one person asked question, what for we are using Zephyr. I will explain that. What for you are using Zephyr for those. Keyboard controller. We know that on our laptop, mostly we are using the scan keyboard matrix, where we are relying on the port 6062 or the 6266, right? For all these passing the scan code or receiving the scan code, passing to the OS drivers. Thermal management, so like lots of different sensors and all is also routed to the EC, right? And the EC can do sometimes the active cooling as well, or there might be other the daemon that is running on the devices which can take care of this thermal management. Sensor is also the similar thing. For example, I am closing my lid hinges and all, right? So like lid is getting closer and all. So those kind of event also EC manages. Last is the power management, and this is kind of evolving, right? Like when the battery charging and like charging your battery, controlling your USB port powers, right? Like activate or deactivate the port power. And latest, I think, addition is like Type C. If somebody is using devices where there is no Type A port, the Type C port is only one, right? And then you have your PD to be negotiated, right? After the PD negotiation been done, right? So how do you manage those between a display, like whether it's a display port or the other ports and all, right? So EC and PD is very, very connected. So this is the overall the job of the embedded controller, and now giving answer to that, how Google is contributing to that. So Google has its own the EC firm like EC layer or EC architecture. We call it the Chrome EC, and after we see the Zephyr, which is basically for us the major the catch point was that it's Linux-like structure. The kconfig, we love kconfig, we love device tree, right? So all our boot firmware that I talk about, depth charge, core boot, Zephyr and all, right? If anything remains constant is that the kconfig and even Linux kernel, right? So we just love how to enable and disable certain builds, right? Because of that, we drive into this Zephyr, and so we can use Zephyr very early in our product intercept. We created the shim layer. The shim layer is basically do a API to API transaction, like between Chrome EC API to Zephyr API transfer, so that we can use the entire Zephyr OS stack as is, right? So the good part of Zephyr is that it is very structured. Like for structure is that like bottom layer you have a hardware, and then there is a platform or the EC layer where it basically deals with GPIO and all, right? So think about something that I'm a platform engineer, right? I don't deal with Zephyr. Zephyr is somebody else in my team that does that, or maybe there's a like community that does that part, right? So like it provides you the modularity. So you use the device tree or kconfig or maybe the GPIO to create your hardware layer, right? Then there is a Zephyr layer, and on top of it you create API, right? So this modular layer allows you a like higher level of abstraction. I think like somebody says that big company like abstraction, small company does not. This is maybe an investment, right? Like how people can be invest, right? I think Zephyr allow you that investment. I'll not go with the architecture of big company, small company. I think Zephyr provide a very great infrastructure, which we love to use and which are we using. We are also committed to move our applications layer, the EC layer, into the Zephyr EC layer itself. We may not use shim, maybe after like couple of generation. And Google is a proud partner of, I think it's a premium partner of the Zephyr project, if I'm not wrong. I intentionally didn't put the like premium word. But this is the motivation for us using Zephyr, and this is a boot flow. So the time you just power on your Chromebook, the GSC, the Google Security chip comes up. We run their TI-50 firmware. It's a you can think this is a Titan chip, and then the the GSC basically holds or maybe the reset signal of the EC while we are running Zephyr as a firmware. After it reset, the EC's job is to complete the power sequence and release the AP, the PCH out of reset, right? And then PCH followed by give a CPU power good. So and when the CPU start resetting, and like the time CPU start execution, like all this additional like the host firmware, right? Application firmware or the like system firmware, like core boot, which basically does all the platform initialization and all. Then there is a depth chart, which basically do all the mode selections and all as a payload. It goes and pick Chrome OS and where all the magic happened. All this generative AI that Sundar always says, right? All it is runs there, right? So this is our boot flow. It is very fast. I gone through it just for the interest of the time. But I have the end of my session some links, some project links which you can pass through. Or as I mentioned, right, there is a device, there is a scan code. Just scan that. You will see what of the product it is running, right? What the firmware it is running on this device, and can you build your firmware by your own, so you can run on such device. Thank you so much. If there is a question, I'm here to take.